Hi friends, welcome to GMK Tutorials. In this video, we are going to discussing about the two-port networks concepts. So let us say before going to this one, what is meant by network? Okay, what is meant by network? Generally, network means that when a number of impedances are connected in together to form a system. So that system is used for some specific application, right? So that is generally called as a network. Simply suppose if you want to define an electrical network, it is a combination of numerous electric elements. Okay, numerous electric element. So let us see first one what is meant by one port network. Generally, network may be represented diagrammatically. It's like a one rectangular box. Okay, suppose this network can be connected to the one more network, so it can be represented in the form of a rectangular box. So obviously we need some input terminals for that one if you want to connect to the another network. So for that purpose, one port network means that any network may diagrammatically represented as a rectangular box. In order to connect it with the other network, it must have two terminals. Let us consider here A comma B are the two terminals. This rectangular box then represents a one port are two terminal networks. So this is generally called as a one port network or else two terminal. It is also called as a, because of it consisting of two terminals, right? It is also called as a two terminal network. Two terminal network. Okay, so let us see what is meant by two port network. So two port network means that if a rectangular box that represents, generally we know that a rectangular box represents the network anukunnam kada. So let us see, rectangular box represents the network. This rectangular box consisting of a one pair of terminals, then it is called as a one port network. Suppose if the rectangular box consisting of two pairs of terminals, that is generally called as a two port network. So let us see here. Let us see here. This is one pair. This is one pair, right? So let us consider some resistor will be like this. If you are assuming like this, okay, I will consider this is a this can be treated as a capital B. This is called as a input side. This is called as a output, right? Okay, so it is also equivalent to the, we can also represent it like this two port network as a, it is also represented as like this also. So let us see here, it is the input side, this is the output side. This is generally called as a two port network, right? Two port network. So from this diagram, how can you define that one? A two port network is a rectangular box consisting of a two pairs of terminals that is generally called as a two port network. One pair of terminals can be act as a designated as a input, and other pair of terminals acts as a output. So it is also called as a four terminal network, because of in case of the one port network it consisting of a two terminal, that's why we can call it a two terminal network. Now it consisting of a four terminals, therefore it is also called as a four terminal network. Okay, for two port network is also called as a four terminal network. Okay, suppose multi-port, okay, or n-port network. If you want to defining the n-port network, let us see here. N-port network, generally we know that network is a rectangular box, right? Network is a rectangular box. This rectangular box consisting of a n ports, that's why it is n ports, then we can call as a n-port network. So let us say this is one port, this is one port, this is one port, this is one port, this is also one port, this is also like this. If the network consisting of more than n ports, more than any two defining it is a 2 port or 3 port or 4 port. If you are considering in general consideration, it consisting of a n ports, we can define it is as a n port network. So that is a very important consider. So like this we can define the n port network. Okay, this is a scenario how we are going to analyze the uh, how we can analyze the just a basic definition of the port. So these two port networks are plays a very important role in the electronic circuit. Suppose if you want to analyze the transistors also, we can with the help of a two port networks only we can represent it. As well as we have a different types of parameters is also there, like Z parameters, Y parameters, it is also called as a admittance parameters, H parameters, it is also called as a hybrid parameters, and last one is nothing but ABCD parameters. So likewise we are also having the G parameters is also. So let us see, first one is nothing but Z parameters. Okay, so let us see first Z parameters. So Z parameters is also called as a impedance parameters, are also called as a open circuit parameters. Okay, Z parameters is also called as a impedance parameter and open circuit parameters. So let us see why we can call it the impedance parameters and all those things. So let us say first one is nothing but Z parameters. Z Z parameters. So generally it is a two-port network. The input and output voltages for the Z parameter, let input and output voltages of Z parameters are V1 and V2, as well as currents I1 and I2. So these are the representation for voltages and currents in case of the Z parameter. We know that generally Z parameters can be represented as V is equal to Z into I format. Okay, so from this we can write this in the form of a matrix format. V is equal to V1, V2, as well as Z can be represented as Z11, Z12, Z21, Z22. So I can be represented as I1 and I2. So this is a matrix representation of the Z parameters, where Z is the impedance matrix. Okay, where this Z is generally called as the impedance matrix. Impedance matrix. Z is called as a impedance matrix. Okay, in a two-port network representation, network is assumed also rectangular box, and the directions of the two-port networks can be represented in the form of a like this. Suppose if you are, because generally network is a two-port network is a combination of networks is a rectangular box, right? So in case of a two-port networks, how we are going to represent? Let us see. See, this is the output ports. This is the input ports. Okay, let us consider like this. I will consider this is a current I1 is and input voltage is V1. So we can also defining plus minus this voltage is a V2, current is in the direction like this. So let us consider this is the two-port network representation for the Z parameters. As well as from this matrix, okay, we can from this matrix we can also defining like this, we can defining like this, v1 is equal to, okay, or else v is equal to, we can also represent them, v is equal to i1 comma i2. So function of i1 comma i2 we can represent it like this also. So from the previous matrix we can represent v1 is equal to general matrix z1 into i1 plus Z12 into I2, as well as V2 is equal to Z12, sorry, Z21 Z21 into I1 plus Z22 into I2. So let us consider these are the equation number A and equation number small b. Now if you want to find out the Z11, what is the value you have to let assume that I2 is equal to 0. I2 is equal to 0 means that it is an open circuit, right? In the open circuit terminals, no current is flowing. Therefore, open circuit. I2 means that port 2 is open circuit because of I2 is nothing but port 2 current. Okay, now port 2 is open. So no current is flowing through the corresponding output port. So from this, when I2 is equal to 0, what happens in the equation number 1? V1 is equal to Z11 I1 plus Z12 I2 is equal to 0. So from this equation, V1 is equal to Z11 I1. So this term is equal to 0. So from this, Z11 is equal to V1 by I1. So we know that generally V by I is equal to resistance. So here Z1 is nothing but impedance, we will consider like this. So it is a forward, okay, no reverse consideration is there. Therefore Z11 is called as a input and output driving impedances. Okay, it is a input driving impedance. Okay, Z11 is also called as a input driving impedance. Let us make one box from this one. Is a input driving impedance. As well as from the equation 2 also we can defining one more parameters. So what is the equation 2? V2 is equal to I1 into Z21 plus Z22 into I2. So we know that generally I2 is equal to 0 in this consideration, right? So from this, V2 is equal to I1 into Z21. So Z21 is equal to V2 by I1. Z21 is equal to forward transfer impedance. Okay, forward transfer impedance. It is also called as a forward transfer impedance. Z21 is equal to forward transfer impedance. Forward transfer impedance. So from this, you have to observe this one. Let Z21 means that where 2 represents the voltage. Okay, 1 represents the current. Okay, like this. Okay, if you are defining like this, you can easy to write also. Okay, when I2 is equal to 0. So let us see, in the another one is nothing but under second consideration from the equations. So let us rewrite this equation. V1 is equal, sorry, if you are considering the port 1 is equal to port 2 is equal to 0, let port 1 is open circuit. So what happened when the port 1 is open circuit? Port 1 is equal to open circuit means that, so I1 value is equal to 0. I1 is equal to 0. So from this equation, V1 is equal to Z11, I1 is equal to 0 plus Z12 into I2. So from this, V1 is equal to Z12 into I2. So from this, Z12 is equal to V1 by I2. Okay, this is called as V1 by I2 is called as a reverse transfer impedance. Okay, reverse transfer impedance. Reverse transfer impedance, right? I think it is clear, right? Now we have to find out one more parameter is left. So from the equation 2, V2 is equal to equation 2 Z21 I1 plus Z22 I2. So from this equation where I1 is equal to 0, in this case I1 is equal to 0, therefore 0, V2 is equal to Z21 into 0 plus Z22 into I2. So from this V2 by I2 is equal to Z22. Therefore Z22 is equal to V2 by I2. V2 by I2. So this is called as a output driving. Okay, na? Output driving point impedance, because of Z22 is output side, right? So this is called as a, we can call as a output driving output driving point impedance, output driving point impedance, output driving point impedance. So this is the way we have to find out the Z parameters. It is also called as a impedance parameter, because of that generally Z is called as a impedance parameters. Z is generally called as a Z is impedance. So it is impedance parameters. As well as these Z parameters can be calculated using open circuit of ports. So it is called open circuit parameters. So this is about Z parameters, right? If you want to analyze the one example problem, let us see the circuit diagram for this one. Okay, find Z parameters. I will represent very shortcut with Z parameters for the following network. They can represent one impedance network like this, one more impedance network like this, one more impedance network like this. Okay, so this is the connection, right? So let us see very simplified. So this is the given data. So from this we have to assume, consider the corresponding variations. This is the current direction I1, this is Z1, this is Z2, this is Z3. This current direction is equal to I1 plus I2. It is a sum of those two. Here also some input voltage V1. It is a V2 minus plus. So this is a data actually they will given. So from this data you have to find out the Z parameters for the circuit. Okay. So apply the, first of all, initially apply the KVL in the loop 1. Apply the KVL in the loop 1. What happens if you are applying the KVL? KVL means nothing but Kirchhoff voltage. So I will consider negative to positive convention can be treated as a positive. So if you are likewise whatever you learn in the basics, some guys are treated as a negative to plus can be treated as a minus also. So but I will consider it as a positive direction. Okay. So V1 minus Z1. Okay, Z1 I1 plus minus, I will treat it's a negative sign convention, minus Z3 into I1 plus I2 is equal to 0. So from this one V1 is equal to Z1 I1 plus I1 Z3 plus I2 Z3. Equation K, I will shift this one left to right, equation from left to right, then I will get V1 is equal to on the left side, V1 is equal to Z1 I1 plus I1 Z3 plus I2 Z3. So from this I can represent V1 is equal to, if we are taking the Z1 as a common value, Z1 plus Z3 into I1 plus, and next one is nothing but I2 into Z3. So finally we can write equation as a V1 is equal to Z1 plus Z3 into I1 plus Z3 into I2. Let us consider equation number C. Okay. Then from the equation, if you are applying the KVL in the, if you are applying the KVL in the loop 2, okay, if you are applying KVL in this direction, KVL, if you are applying a KVL in loop 2, it is a, I will consider it as a loop 1. Then what is the equations how we are going to represent? V2, just take V2 minus Z2 into current direction I2 minus Z3 into I1 plus I2 is equal to 0, because of it is the same direction current. That's why I1 plus I2. If it is opposite direction, we will treat I1 minus I2 or I2 minus I1 also, right? So from this, V2 is equal to, if you are shifting all the this term to the right side, then we will get Z2 I2 plus Z3 I1 plus Z3 I2, right? So from this, we have to represent I1 term is the first one. I1 is nothing but Z3 I1 plus, if you are taking I2 as a common, Z2 plus Z3. Okay, this I2 is it. So let us consider equation number D. Now, if you are comparing this equation number C and D with the standard equations of the Z parameters, that is nothing but I can represent equation number small a and b, then Z11 is equal to what value? Z11 is equal to which value is matching here? Z11 is equal to first equation number C, Z1 plus Z3. Therefore, from this equation, I can represent as, from this equation I can represent it as Z11 is equal to Z1 plus Z3, right? As well as Z12 is equal to, from this Z12 is equal to, comparing this one, Z3, as well as Z21 is equal to, from this, Z3, as well as Z22 is equal to Z2 plus Z3. So these are the Z parameters for the above equation. That means if the circuit is in the form of a T-type network, we can easily find out the corresponding Z parameters, but simply by taking this one as a consideration, right? If you are taking this one, we can easily find out this one. So let us see one more problem related to the Z parameter, very simple problem. Okay, then you will get some idea, right? So let us see for this one, one more problem related to this one. If the networking consisting like this one resistance, it is also having one more resistance, it is a T-type network. So let us some positive voltages. I will represent one more user color. This is, it can be treated as a V1, it can be treated as a V2, alright? As well as we can write some current directions also given in this one. It is I1 current, resistance of this one is equal to 5k, this is called as a 12k ohm resistance, this is a 3 kilo ohm resistance. These are all resistances, kilo ohm resistance, right? So if you are applying the KVL, okay, in this direction, KVL in loop 1, KVL in loop 2. Okay, now we have to find the Z parameters. Question is find Z parameters. Okay, now from this one equation, if you are applying the KVL, V1 minus 5 into, these are all in 5 kilo ohm, just I will represent all in 5 kilo ohm resistance into I1. So no need to represent 5k, we can each and everything all in the same letters, so you can directly represent. Okay, so for that purpose I can applying like this: 5 I1 minus 12 into I1 plus I2 is equal to 0. Alright, now from this equation how we are going to calculate that one? So V1 is equal to 5I1 plus 12I1 plus 12I2. From this equation V1 is equal, if you are taking I1 as a common, we can get 17I1 okay, plus 12I2 as well as second equation. If you are applying the KVL in the loop 2, V2 is equal to directly I can represent 3I2 plus 12 into I2 plus I1. Okay, now V2 is equal to, let us consider this equation number is equal to E, I will consider is equal to 3I2 plus 12I2 plus 12I1. Now from this equation V2 is equal to, if you are taking I1 as the first one, 12 into I1 plus 12 plus 3 is equal to 15I2. Let us consider F. If you are comparing E and F equations with the standard jet transform equation, as well as these two also similar to the previous network, right? So it is also similar to this network. Okay, similar to these two networks, right? We can directly find out the Z1 is equal to by adding those two values. So from this also we can comparing this one, we can get Z11 is equal to, so from this one it is equal to Z11 is equal to 17k because of all in kilo ohms range, 17 ohms range, as well as Z12 is equal to, here from this Z12 is equal to 12 kilo ohm, as well as Z21 is equal to, from this 12 kilo ohms, as well as Z22 is equal to, what is the value of this one, 15 kilo ohm. Or else simply we can directly without applying any KVL in this equation, okay, without applying KVL in this equation, okay, just we will find the values to this kind of the circles also. Okay, so let us see here. So from this, so it is also similar to this one network, therefore Z11 is equal to Z1 plus Z3, therefore 5 plus 12 is equal to, so 5 plus 12 is equal to 17 kilo ohms. So directly you can get, as well as Z12 is equal to Z3, that is equal to 12. Okay, 12 kilo ohms, as well as Z21 is equal to Z3, therefore that is also equal to 12 kilo ohms. Z22 is equal to, what is the value? Z2 plus Z2 value 3, Z3 value 12. 12 plus 3 is equal to 15. So within a 1 minute of time, you can directly find out the Z11, Z12, Z21, Z22 values from the circuit, from the given circuit, by considering the corresponding consideration. So I hope this guys, this video is very helpful for the jet parameters. So thank you for watching GMK tutorials. Okay, GMK tutorials, as well as we will consider some more parameters, some more conditions will be there in case of the jet parameters. Just parameter. So I will mention the just conditions for this one, like reciprocity condition and a symmetric condition. So just I don't want to going very deep into this one. Reciprocity condition is equal to reciprocity reciprocity condition reciprocity condition in case of the jet parameters is equal to Z12 is equal to Z21. So reciprocity means that if you are changing the V by I as well as I by V in the both sides, the total value is must be equal to same. As well as symmetric condition in case of the Z parameters is equal to symmetry. Symmetric condition is equal to Z22 is equal to Z11. This is nothing but symmetric condition. This is nothing but reciprocity. This is nothing but symmetric condition. These are the very important properties in case of the Z parameters. Okay. If these two values are same, then we can call as a reciprocity as well as a symmetric conditions of the Z parameters. Okay. So thank you for watching GMK tutorials. If you are my channel, subscribe cheskokonte. So please subscribe our channel. Okay.